Imagine you're drifting through the coldest regions of the solar system, where the sun looks more like a distant star than a blazing ball of fire. In this place, temperatures are so low they can freeze most gases solid. Most comets out here are little more than icy time capsules, ancient, frozen relics that barely move or react. They quietly orbit or pass through, occasionally warming up only when pulled closer to the sun. But then, something unexpected broke that silence. Astronomers observed an object in deep space behaving like it completely missed the memo on how comets are supposed to work. It wasn't warming up near the sun, it wasn't following a traditional orbit, and most shockingly, it was spewing water vapor at astonishing rates, as if it had a high-powered jet engine strapped to it. This was no ordinary comet. This was something alien. Something that came from a different star. And it came bearing secrets scientists are still trying to crack. Meet 3I Atlas, aka the third officially confirmed interstellar object to ever enter our solar system. You've probably heard of the first one, Oumuamua, the strange oblong rock that zipped past Earth in 2017 and sparked everything from scientific theories to alien speculation. Then came 2I Borisov in 2019, which looked and acted more like a traditional comet, but was still from beyond our solar system. And now we've got 3I Atlas. Discovered in 2019 by the Atlas Survey System, a telescope network designed to spot dangerous objects that might impact Earth, this particular rock didn't raise many red flags at first. It looked like a run-of-the-mill, icy body just drifting in space. But then came the analysis. Astronomers looked at its trajectory and realized it wasn't in an orbit around the sun. In fact, it wasn't orbiting anything. It was moving so fast and on a path so bizarre that it could only mean one thing. It came from outside our solar system. It wasn't bound by the sun's gravity. It was just passing by. Hence the I in its name, short for interstellar. And that part is key because it means this object formed in a completely different planetary system, different rules, different chemistry, different environment, and apparently, when it comes to water vapor, a whole different set of expectations. Once astronomers labeled Atlas as interstellar, they started watching it more closely. But what they saw surprised even the most seasoned comet watchers. Atlas was behaving in exactly the way a comet shouldn't when it's that far from the sun. Let's break this down. Comets are often called dirty snowballs, frozen mixtures of rock, dust, and ices that heat up when they approach the sun. That heat causes the ice to vaporize and release gases, forming a glowing cloud called a coma, and sometimes a trailing tail. But here's the catch. This process only kicks in once the comet is close enough to feel the sun's warmth. The farther from the sun it is, the less active it becomes. Standard science. So then why was Atlas showing massive water vapor release when it was still so far out? Like, really far. It was leaking water at distances where the sun's warmth shouldn't even register. Yet data showed it was already forming a huge vapor cloud and letting off steam like it had a secret heat source. It made no sense until researchers realized we might not be looking at a normal comet at all. The breakthrough came in 2024, when a team of astronomers published a new study analyzing Atlas's chemical activity based on far ultraviolet observations captured by space telescopes. What they found? Shocking. Atlas wasn't just releasing a little water vapor, it was blasting it out like a high-pressure fire hose. One scientist put it in startlingly simple terms. It's like a fire hose running at full blast in deep space. Think about that for a second. We're talking about tens of thousands of pounds of water vapor blasting out every single second from a rock hurtling through the vacuum of space. That kind of activity wouldn't be crazy if the comet was directly under the sun's nose, but it wasn't. It was located as far out as Jupiter's orbit and beyond, where the sun's heat is barely strong enough to power a calculator, let alone melt ice embedded deep in rock. That raised serious questions. How could it be so active out there? What kind of materials could possibly be vaporizing that easily in the cold of deep space? And more importantly, what does this mean about where Atlas came from? To understand Atlas's bizarre behavior, we need to look at what it's doing, but where it may have come from. Most comets in our own solar system formed in the Kuiper Belt or even farther out in the Oort cloud, distant regions packed with icy debris left over from the solar system's formation. Stuff out there is colder, older, and filled with volatile compounds that easily turn to gas. That could explain Atlas. Scientists now believe this comet likely came from a similar distant region, just around a different star system entirely. Its high level of water vapor, especially this far from heat, means its core may be loaded with volatile ices like carbon dioxide, methane, and super easily evaporated water. It's like an ice-rich cannonball that formed on the outer frontier of a foreign star, was knocked loose, and spent possibly millions of years drifting through empty space, before casually blasting through our cosmic backyard, spraying its secrets as it passed. This isn't just a comet. It might be a frozen messenger from a planet-forming nursery light years away. The more we compare Atlas to the other two interstellar objects, the more it sticks out as something unique. Take Oumuamua, the original cosmic mystery rock. It was long, thin, pancake-shaped. Astronomers are still not sure, and it showed no visible outgassing at all. People theorized everything from alien technology to asteroid fragments. It was weird, dry, and left faster than anyone could figure out what it was. Then came Borisov, which looked more familiar, a gassy, dusty comet with a standard tail. It activated near the sun and behaved like something you'd expect from within our own solar system, even though it clearly wasn't. But now, 3I Atlas, whole different DNA. No one expected this much water activity this far out on something not even from our own planetary neighborhood. It's like someone combined the strangeness of Oumuamua with the dustiness of Borisov, then cranked the volatility knob to 11. This could be our first look at an entirely new category of cosmic travelers, icy nomads formed from deep freeze chemistry we've never been able to study before. Here's where things start getting wild and honestly a little unsettling. Atlas is the third interstellar object we've found in just a handful of years, and that's without even looking very hard. Most telescopes aren't scanning for high-speed rogue comets from across the galaxy, but more sensitive surveys like the Vera Rubin Observatory are coming online soon, and once they're fully operational, we may start spotting these objects by the dozen. Think about it. If Atlas is just one of many, that means rogue, icy comets are constantly zipping between star systems, undetected. There could be droves of them, carrying strange chemicals, alien ices, or even organic compounds. Some scientists have floated the idea of panspermia, the theory that life, or at least the building blocks of it, can travel across galaxies via icy comets or asteroids that smash into young planets. Could objects like Atlas be delivery systems for life itself, carrying exotic materials across the cosmos, waiting to crash into a planet with just the right conditions? It sounds like science fiction, but after Atlas, it's a little harder to wave that theory away. For now, Atlas is already making its way out of our solar system, never to return. And despite all we've learned, one big question still hangs in the air. Where exactly did it come from? Astronomers tried tracing its inbound trajectory and came up with rough estimates of its origin point, a patch of sky in the constellation Serpens. But here's the kicker: space is constantly shifting. Planets move, stars drift, and galaxies twirl. Even if we can trace Atlas's path, the star system it came from might not even be in the same place anymore. It could have been a system like ours. It could have circled a dying star. It might have formed in a violent, chaotic region filled with collisions and debris. We may never know. But what we do know is that by flying through our solar system, however briefly, Atlas revealed just how little we actually know about the space beyond our own front yard. In the end, 3I Atlas isn't just an icy rock. It's a window into another star system, a frozen time capsule that's been on a cosmic road trip for who knows how long, and just happened to swing by at exactly the right moment for us to notice. It came from somewhere we've never been. It's made of materials we've never seen, and it's acting in ways comet scientists still don't fully understand. And yet, beyond all the scientific analysis, data crunching, and orbital math, maybe the most humbling part is this. We didn't go looking for it. It came to us. And it made one thing clear: our solar system is not alone. There are roads between the stars, and travelers use them.